I think what we're going to do today is we're going to start here. I've got to shoot this one in multiple parts, and I'll explain to you why. So the tubes that we're here to talk about is this here, the 31JS6. Okay, let's go up here to the top of the list. Our heater, we need to set it to 30 volts, obviously, because this is a 30 volt tube. Our gain, or sensitivity, we're going to set to 58. And then our socket, we're looking up here, socket, is set to 21. Now when we see a bunch of dashes and then the Z1, what that means on the old venerable B&K 747 tube tester, which my buddy Zane at Big Rig Radio found for me at Hamfest a million years ago, and I rebuilt it, means we do this. All of these are set to the dot marks all the way across. So our heater we have set to 30, and our sensitivity we have set to 60, roughly. So our sensitivity here is supposed to be set to 51. That's the second row. We'll set it to 51. I actually had it overclocked. Okay, so what we're here to talk about today, we're going to let this tube just cook for a hot minute. And by the way, a tube tester without its manuals, worthless. Absolutely worthless. And I very much intend on taking this 747 tube tester manual and having it completely copied and rebuilt, because it's starting to fall apart a little bit. And then here's the 747 service manual for this particular device. Not the hardest paperwork to find, because this was the best tube tester, portable tube tester that man ever made, in my humble opinion. I freaking love this thing. The first one of these I ever seen was owned by a friend of mine. His name was Squeaker. I wouldn't call him a friend, I'd say an associate. An associate that I knew back when. His name was Squeaker. He's out of California. He showed up out here in Idaho, and he was over at another friend of mine's house, or another associates of mine. He's not a friend of mine anymore. A guy ended up being anyhow. He showed up with his big camp trailer, and at the time there was this big box of 8950s, and you know, that's back when 8950s were cheap. And I say that tongue-in-cheek because the 8950 today is like $130, $140, $200, right? Well, there was a big old tote that probably had 20 of them things in it. But me, the conglomerate corporate radio operators out here, none of us had a tube tester that would test the 8950s. And here's old Bill in his giant fifth wheel, or not giant fifth wheel, his big motorhome, goes, "Oh, well, I've got that with me." And we're both looking at him like, "Dude, you're on vacation." What? He goes, "Man, oh no, radio's my life. I don't leave home without certain tools." And I totally get it now. I totally get it now. Now that this is like my business, we're fast forwarding now 20 years into the future, 15 years into the future. I get it now. There's certain things I just don't leave home without. Like let's say I'm going to go to Puyallup Hamfest. You can bet money that this tube tester is somewhere around. The voltmeter, drivers, high voltage probe, soldering iron, just, you know, your basic portable get shit done electronic equipment. The advantage to this is this thing literally tests every kind of sweep tube on earth. And I'm pretty sure if I sat down and read the manual long enough and thought about it long enough, I could probably make it so it tests one of these as well. You know what I mean? So the guys that built this sharpened their pencil pretty good. And for what I need it for, this thing is the shit. Now the reason we're taking this much time to talk, because I want to let that tube really thoroughly warm up. There has been a debate between me and the owner of this Eagle. This is a Golden Eagle 750. Now, he has owned this amplifier since he was 13 or 14 years old. That is the only reason it is here. As you guys know, I just recently took on all my work for 2023, and I had several people call me wanting me to work on their sweep tube amps. The problem with that is that the amps are very flimsy, they're very delicate, and it might work perfectly here, and then when I get it shipped back home, there might be something else that is broke just because it's going through shipping. Because remember, most of these things were built in the 40s, late 40s, the 50s, and the 60s. And the reason I say the late 40s, like 48, 47, somewhere in there, is about the time that the CB frequency that we have today started to become a thing. So I can only assume, okay? It's not like you can go Google when were these made. You might find somebody on some rare forum that says, oh, well, I knew my uncle Kevin John Smith that worked at so and. Believe it or not, the some of the MERS frequencies that we use today were actually the first. That little lot of frequency was where the first, like, quote, citizen band CB frequencies were at. If you look at the history of things, the bands have been jumbled around over the decades a couple times, but a lot of this stuff here might have been put together in the 60s. Well, that's great. So 60, 70, 60s, 70s, 80s, 90s, 2000, 2010, 2020. This is a 70-year-old device, and that's being generous. If I'm able to get it running here, and the reason I can say it's probably done in the 60s is because the kind of caps are not paper wound, but they're aluma body paper on the inside. And the heat shrink, the PVC heat shrink, that wasn't really commonly a thing until in the 60s. Once again, one of the things that come out of the space program, by the way. They're old and they're delicate. And I found that 9 times out of 10, these are way more headache to work on, maintain, use, and fix than they're worth, especially taking into account how much power they put out. And all the tubes for all of this stuff is getting way, way out of sight. And $200 for an 8950, $130 for 6LQ6 or 6LF6 or 6JF6. It's just getting silly. And then you don't even know what you're buying, because everybody saves their little tubes, apparently, their little tube boxes. And I don't know about you, I mean, I'm surrounded by some pretty smart people, my wife and my kid and so forth. They'll take this tube, let's say that's this one that's in the tester right now that might be completely dead, and they'll be like, oh, well, it says right on it Amprex. So they'll put it inside the Amprex box and seal the box up. They'll put it on eBay. They'll put it up for sale and say as is, 25 bucks. They get their money, they ship you the tube, you get it, and it's flat. So it's not really worth it. But when it comes down to a sentimental thing, I will do my best to lift mountains, move the universe, right? That's our job. That's my job. So yeah. This thing's had an interesting life. He's told me a lot of history about it. Now, it has been here for a while. It's been here for over a year and a half now, waiting for me to get to where I can work on it. This is one of the last things to show up. So I'm starting to work through the last tail ends of the equipment that was sent in for repair 2.5 years ago, when you guys bombarded me with 800 pieces of equipment. I'm getting down to the tail end of that. So the conversation happens with me and him. I call him. Hey man, what's going on? Okay. Hey, you gonna ever look at my amplifier? Yes, I can do it today. I thought I'd grab this real quick, take a quick look at it, because these things are incredibly easy to work on. They're no degrees in rocket science bullshitium needs to be had to work on these things. They're the most simplistic tube amplifier, period. Well, first he told me, in his memory, that they were 6 JS6s. Well, one of these, I already put it away. Okay, so I found myself a 6JS6. I have one in my whole shop and myriad of shit that's in this place. Let's look at the pin count on the bottom of these tubes. It's very reminiscent of like an 8950 or something. There's quite a few pins on the bottom of this tube. Look at this. Okay. 6JS6 has the exact same number of pins, but it's a 6-volt filament. Well, I don't have a large stock of sweep tubes up in here, so I started thinking, I'm like, man, I don't know. I've got all of these 31-volt tubes or 30-volt tubes, and they sure look like they would fit in this thing. So I go down the path, really, we're going to give this tube its best opportunity to succeed it's ever had. I go down this path of thought, and he's insistent that they are a 6-volt tube. And I'm like, not with that pin count. I mean, they could be, but they're not. And the reason for that is because I flipped the box over and I looked at this. Let me flip the amp over. Let's look at the tube socket on the bottom. Okay. The tube socket is wired in series. Or pardon me, wired in parallel, not wired in series. So this blue wire is our filament voltage. So we've got our AC voltage that goes in on one side, and then usually over here one of these pins is going to be our out leg. It's going directly to ground. So whatever this voltage is what dictates what that tube is. So let's say we put 6 volts on here. Okay, 6 volts here, going directly to ground, 6-volt tube. Now, it's open to variation because we can take and put 2 in parallel, 2 in series. So if we had a 12-volt filament lead, so we have 12-volt coming here, the way this would be wired is on the out pin, this leg would come over here, and then that pin over here would go to ground. Tie the 2 6-volt tubes together, get 12 volts. And then off of that lead, you'd have another wire running over to this tube socket, and it would loop to this socket and then go to ground. That's not what we have here. We have this lead coming here, this going here, this going here, and they're all going directly to ground. Okay? They're not in series, they're all in parallel. So, then he says to me, he goes, well, the fuse holder on this thing was broke, by the way. He says to me, well, I hooked it up, and I turned it on, and as soon as I turned it on, the fuse blew and made a loud bang. I was like, oh, okay. So for me to establish what the voltage of the tubes is, I've got to bring it up. And I said, well, that's simple, bud. The way this works is this thing's wired 110 volts. Flip this lid up. I don't want to melt the lid on my tube tester. Okay. It's wired 110 volts. So here's your case ground. This is your return lead, and this is your hot lead. The hot lead comes up, goes through the fuse holder, comes down, goes to an on-off switch. So 100% of the juice potential goes directly through the switch, comes out of the switch, goes over here, goes to this distribution bus. This red wire runs over to the fan. And this white wire runs over to the plate transformer, filament transformer, multi-tap transformer. This one transformer does the job of multiple different power supplies. It's got a tap coming out to run the relays, a tap coming out to run the light bulbs, a tap coming out to run the filament, and a tap coming out for the high voltage. Insert in one of these tubes, you'd have another tap coming out for your negative power supply with a neutral flop ground. First thing I did is I went in here and I sucked all the cobwebs because it looked like a spider had moved in here and made home. I don't know if it happened here or if it happened there, but I got out the Ryobi shop vac and the paintbrush and went and sucked all the little dead critters out of here and got it cleaned up to where I felt comfortable with it. And I told him, I said, listen, I'm going to replace your fuse holder. It can only be a couple things. If it's popping the fuse as soon as we turn it on, depending on if this has got a switched high voltage circuit, some of these sweep tube amps, the high voltage circuit is not switched on until you key the amplifier. That is always going to be, and if it pops the fuse as soon as you key it, that's always going to be a high voltage issue, either it be with the caps or the rectifier circuit. Well, this uses a voltage doubler. And what do I mean by that? There's a half wave rectifier here, and the other half of the circuit, the other half of the high voltage circuit is these filtering caps. Okay, this is the 12 volt side, this is the high volt side. They are not visibly leaking, they're not glowing underneath a fluorescent light, there's no dried up jism that's on the outside of the cans, and there's no burned up traces. It's like, okay. So then I go and I check my half-wave rectifier circuit down here, my 1000-volt diodes. These are probably 1 amp, 1000-volt diodes that run down here. The beauty of this sweep tube amplifier is it's actually relatively easy to work on. Most sweep tube amps are a nightmare, and you have a hard time getting access to a lot of the things. This is the bottom of our rectifier bridge. So you feed AC on this side and AC on that side, and blah-blah, Bob's your uncle. I go in and check all these diodes, and none of these diodes are popped. So usually what happens on these 67-year-old devices is our filter bank dries out, these guys. The cap will dry out and go bad, and it'll present a short to the high voltage supply, the rectifiers down here. Cap goes bad, blows the diode shorts out, presents a short to the filament transformer, plate transformer, multi-tap transformer on its secondary, otherwise its output side, which then in turn presents too much of a current draw for the primary side, which blows the fuse. 9 times out of 10, that's what happens. So I told him this is going to go one of two ways. I'm going to hook this up, put a fuse in it. I'm going to short fuse it for like 5 or 6 amps to try and protect the precious transformer. The way the order of value goes in all of these amps, all the sweep tube amps these days is in this order. The tubes, transformer. Everything else, garbage. The reason I say that is all of this other stuff is relatively cheap, and we can find most of it short of these, which these are starting to get a little bit hard to get a hold of. Okay, there are places to get these, believe me, I'm familiar. The cost of these is relatively high. When I was a kid, it was like $5 or $10 for the cap. Now we're talking like $30 or $40 for one. That's if you want old stock. I do believe that there's a company out there that's still making these, but the quality isn't the same and they have a tendency to break down. Needless to say, the unobtainium bit out of this whole cabinet is this transformer. I said, man, if your transformer is shot, I'll send it back to you for sentimental reasons, but it's not worth trying to repair. Trying to have this transformer rebuilt is like 4 times the cost of this unit completed and running. Especially since now I've been able to establish that it runs on a unique voltage for the filament. The filament voltage is what dictates what tube goes in these sockets. Remember, he's pressing for the idea that this has a 6 volt filament on the tubes. And I'm like, brother, I don't have any 6 volt tubes in the shop that have that pin out that fit in here. Moreover, I found these 31 JS6s in a cardboard box with your name on it. So I'm pretty sure these are your tubes. He's like, no. I'm like, yes. No. And he's like, yes. No, yes. We had a disagreement. So, needless to say, I replaced the fuse, and I went ahead and I went, okay, and I hooked up the variac, and I'm going to do the same test I did with you guys right now to prove my point that I did with him on the phone. I brought it up slowly on a variac, which you always want to do on this old stuff. Remember how you apply the variac? I remember, once again, it's one of these things I learned from my buddy Squeaker. What was a variac? How does it work? And what do we use it for? And how do we use it? One of these things he started teaching me. Smart guy. Absolutely smart man. And kind. And what I mean by kind is he's willing to take a dumb ass like myself and tell me something and then repeat it 55 times until it sinks into my dumb brain bag. Okay? To me, that takes patience and for a person to be kind. So now what we're doing is we're hooked to ground, the same that the opposite side of the tube is, and now we're hooked to our filament lead. Okay? How do we know this is our filament lead? Over a decade's worth of experience looking at sweep tube amplifiers. We can go with that, and that's the arrogant way of answering that question. The non-arrogant way of answering that question is we went and we pulled the tube, socket pin base, crossed that with multiple different tubes that we know can fit into that pin base, and found on an average that this pin is most likely across most of those tube platforms our filament lead. You only have 2 leads for your filament. And usually you're going to put, if it's like a 3000, you're going to put 3.5 volts here, and you're going to split your voltage with a 0 tap in the center so you can control a bias. It's not the way that this tube works. This is literally, we ground the grid, so you can just dump in whatever your filament voltage is going to be on one side of the tube and then ground the other side of the tube. All right, now I've got you up to pace where I'm currently at. So before I go and get really stupid by talking a lot on camera, let's make sure nothing's shorted out. Nothing is shorted out. Okay. So we'll go ahead and we'll turn on the amplifier. The filament volts for this particular box are 28 volts. They make a 21 6JX6 or sorry. They make a 21 6JS6C tube, which is very rare, but then that would make the filament voltage too high. This is a 30 volt tube. Well, these are all 30 volts. All of these sockets are 30 volts. They have the same power supply. Same thing's going on over here. A little blue wire loops around, it hooks up right here. It's the same thing. It's 30 volts across the tube. So I'm sorry, my man. I love and respect you, brother, but I got to tell you, right now, as far as I can tell, this uses a 30 volt tube. That, and I found the cardboard box that your tubes were in with your name on it. And I just by chance happen to have just the right number of tubes to occupy this cabinet. Okay. Now, I don't care who you are. I have given more than adequate amount of time. Oh, come on. All right. I have given this more than adequate amount of time for this one particular tube to warm up. We verified that we have all of our tube settings correctly. So first we're going to look for shorts. We have none. We're going to hit our grid emissions button. We have 0. We're going to hit test number 2. And now we're going to bring it around for test number 1. This tube is bad. The grid's in the green. We have no shorts. Life test, test 1. This tube is bad. It has been run to the end of its life. Okay, now that we've established that, this tube had a lot of Sharpie numbers written on it. I've gone and put 10 on it because that's what it is. Over here is 10, but up on the top it says 100. Right here, it says 100 right here. 10%, 10%. At some point or another, I have pulled all of these tubes and I tested all of them at some point or another. Put them back in their boxes and put them back on the shelf. Well, here's the end result of that. 60% is what this one says. And I think that most of these numbers that I put on these tubes is going to be a little generous. So tube's back in a socket. We're going to give it a minute or two to warm up. This is the other 60% tube. And they are slightly taller, and these are a Japanese-made tube. This is an Amprex. This is a Zenith. This one's a Zenith. This one here is a Svetlana. Zenith is the one that we just tested. So I would bet money, having a little bit of tube operational experience in my life, which one of these is the hot one? That's the hot one. That's the one we just got done testing. And just looking at this tube, you can tell it's had a hot life. But there's nothing left inside this tube. It has nothing more to give us. Okay? Shorts look good. Grids look good. Test number 2 looks good. Now if I sit here and I let my finger cramp, zoom in here where you guys can see what I'm seeing. If I sit here and let my finger cramp, 20 minutes from now, this will slowly eke its way up to 60-ish, which is the question mark zone for these tubes. To me, we want to be over here in the green zone, which is 70, 80, 100, 120%. And really, you know, you got a really good tube when it's in 120%. Okay. Like I was saying, the numbers on here that I give are very generous. Okay, it's looking good. So now if I press and I hold this button, while the tube is warming up, while it's coming up in operation, ooh, it's really climbing. It's really climbing. It's really no, it's not. Barely eking up there. The reason that we have to be concerned about the percentage of the tube and its ratio is this voltage here, this chart here, so I don't ever touch the plastic on this thing. A little bit of static electricity. It's a static electricity issue here. I should not have touched the screen. Man, don't make me go get a dryer sheet. Don't make me do it. Don't make me do it. Fun, right? Close enough for right now. Once we get below the 55% mark on the scale, it says, okay, high voltage reject. When you get that low with the gain of the tube, you run into a problem where you have to worry about the tube's high voltage, the anode and the cathode being able to cross over to each other on the inside of the tube and cause a short, high voltage short. I guess magically overnight, this tube picked up more output emissions. So technically that one's okay, according to the tester today. Of course, now that I've gone and I put my meat beaters all over it, it's gonna act crazier than a frickin' barn full of clown pubes. I have a feeling that these two tubes here were the driver tubes. That one tested at 30, that one's 35, and this is 40. Let's put the 10%er back in there. Do this double blind. I have a feeling that these two tubes are our drivers and these are our final sections, and that's usually what happens, is that you'll find that your final section tubes are way lower because they take way more punishment than the drive tubes. Remember, these are 30 or 40 watt drive amps, right? Supposed to be in theory. But then we'll take 120 watt tube and drive that into 4 other tubes. The saying, there's a reason the final section goes dead quicker. All right, so we'll take this as a control because we just tested this one on video. This is our 10%er. And that one's within spec of what we just seen as a result. I can sit here and hold my finger on this till the cows come home. It's not going to come up. Okay, so that one tube is actually 70% tube. And I'll make sure to send it back. The problem is I don't trust any of these tubes. They've all been beat down, like hardcore beat down. I think on this one I got 35%. 30%. Doesn't matter. Most of these tubes are way down here and that we must discard because we have to worry about an electrical short. And I'm pretty sure that that 10% tube, this one here, had a short in it when he keyed it up. There's another problem, which I'll quickly overcome. I'm going to show you here in a minute. But this is a two-part deal. This is the intro to it, me explaining to you what's going on, why we're at this point, why I predict this is what the results are going to be, backfill portion. And I'm going to put this away, put all the tubes away, put the amp away, get on the internet. We're going to order up more tubes, many, many more tubes. And then we're going to test them. We've got to get a good set of tubes to make that run. 9 times out of 10 with all sweep tube amplifiers, if you go to run it and short of a high voltage issue or a filter issue in the high voltage section, the tubes have just been run to the ground and they just need to be replaced. That's the beauty of the tubes, is that they're so rugged. This one I had written on it at 30. That's being generous at 30 here, I feel. 25, 26. Okay. Our test points prove valid. This is a 35%. This one's at a 40, 45%. These are all junk. Our final stage tubes are junk. And I think that everybody's on the same page with me now. So we've proven that these are this guy's tubes. We've proven that the amp is this is what it wants. And I know that there's somebody out there that has the question, but BBI, what happens if you change this to 25 volts? Because then that would be within spec. Doesn't skew the test results at all. I'm telling you, it's a 31 volt amp. Now, the reason that this is also another big deal is because according to most of the places on the interboob, these were only built with 6 volt tubes. These things were built with whatever the tubes were that they could find that day that were the cheapest, in my opinion. That is what I have seen over and over and over again with sweep tube amps. I've had a Galaxy 1000 come in here at one point. I had a Galaxy 1000 that come in here at one point, and most of those are supposedly the 6, they're a 6 volt or an 8 volt tube. Well, I had one with these same tubes in it, 31JS6Cs. Telling you, it's usually with what they can find is the cheapest thing to put in here at the time. Now, the beauty of this is these 31JS6Cs, okay, they're somewhere between $12 and $15 a piece. Versus if we were to do 6LQ6, 6LF6, the 6JS6Cs, those are $70-something a piece. So this guy's going to get off really, really easy on his repair bill. Now, this gentleman here had some kind of other amp that he needed a key-in transistor for. And so he thought he would come in here and he would, right here next to this wire, down here, I need a point and stick. Point and stick. This transistor, he cut it out. Well, it's paired with 2 other transistors that are down in there. The TN214Gs, or is that a 1? I would like to think it's a 1. I did a quick little search for that part number. I didn't get a whole lot. But that's okay. I'll take some time. I'll sit there and I'll look at it and I'll figure out what's driving what. If that's the preamp transistor, I don't know if I'm going to be in too big of a hurry to make it happen for this captain. That's actually the owner of this amp right now trying to call me. I don't know if I'm going to be in too big of a hurry to make that happen for this captain, but I'm pretty sure I'll be able to find a relatively easy cross. It's going to be a PMP or an MPN. All we do is got to figure out which way a base emitter collector goes. Not that hard. What I can remember as a kid sitting there for hours trying to figure this out because, well, I was young and dumb and still learning. So I'd really like to figure out where this burn mark come from. It's on the edge of the cabinet lid here. Let me back out so it focuses a little bit better. I want to know what caused this. I mean, that is a burn to beat all hell. Nice big scorch mark, but I can't find where it came from. This is our high voltage lead here. It comes off of our filter bank / other half of our rectifier circuit. So I just don't see that having any burn marks or arc overs on it. I have not tried to key this up yet because until I can establish what this transistor is, I'm not going to go that route. But needless to say, this is the beginning of part 1. Like I said, I'm going to button this all up, bag up all the screws. I'm going to put all the tubes back in their boxes, put the tubes in here, move this off, going to order up some tubes, and we'll be back to this in a week. So, through the power of cinematography and my due diligence to try and do my job right, that will happen for you guys on YouTube land right now. So here we are back on the Eagle. What is this thing? An Eagle 750. And we got ourselves some brand new, supposedly, straight from eBay, new old stock tubes. So, that ain't hooking up any high voltage to it. We're going to turn the tube on. Got our heater set at 30, our sensitivity set at 59. We've got it in the right socket. Brand new, supposedly. Brand new, supposedly. Brand new, supposedly. I did get a message from one of the sellers. And he says, make sure to run these for a couple hours before you try to light them off and whatever. Shorts. Oh yeah, look at that. And climbing as we warm up. 85. 90. We'll call that 95%. That's a good deal. Okay, so watched a whole YouTube video this last weekend about the viability and life of tubes, new old stock, and the host of this little program said that he took a bunch of flack for making the statement a few years ago that we would never run out of tubes, specifically sweep tubes and certain types of vacuum tubes that are used in the audio community, specifically some of these sweep tubes, and how there's like one company left manufacturing these things. That's a good tube. It's 100%. And He goes, how the tube community descended on him. Like, ah. No, he's not talking about peanut tubes. He strongly feels that we'll never run out of the peanut tubes. And I have a tendency to agree with him. I don't think we're ever going to run out of little peanut tubes. But some of this stuff, like the 6LF6, 6JE6, 8950s, and that kind of thing, we are running out of those. And that is reflected by cost. When the cost starts going up, we know that we are running out of stock. Either that or everybody's buying into a global conspiracy. So, up they go. And they're universally jacking the price up all across the country, and everybody's talking about it, and no one's actually making it. Somehow everybody's communicating and not making it public knowledge that we're needing to jack the prices up falsely. I don't buy into that theory. I think we're physically running out of stock. So I say you all be kind to your tubes. Be grateful for the tubes. And don't beat the ever-living piss out of them. %, itself. More than good. All right. So we'll get these tubes tested. And what I'll probably do is I'll throw them in the amp and just let them sit there and idle with no high voltage applied. I don't think the high voltage on that amp actually kicks on until we key it, but anywho, I won't hook anything to the anode. We're going to let these cook for a hot minute. Even though all things considered, these are relatively cheap. So it says written on the box 105% on that one. That one says 111%. I'm sure if we let them cook for a little bit, we'll get them numbers out of them, but for the most part, I want to make sure that there is no shorts. That's the most important thing for right now. Oh, 80% in climbing, no shorts. Yeah, 85% and slowly climbing. So like I said, if I'd let them cook for a little bit, we'll get higher numbers, but our goal is to determine if they're shorted out or not, which you're not. This one says 112% on the box. It beats the 5, 10, and 25% and 30% we were seeing on some of these, right? So, shorts, nothing. Reset. Live test. And we wait. And we wait. And we wait. We do the happy dance as we wait. There we go. $85, 86%. That'll be perfect. Okay. This one says 108. So, go Flea Bay. Grateful for it. Shorts, nothing, grids, nothing, overload. And we wait. So 4 RCAs and 1 Zenith, which I'll take it. Oh, yeah, that's a good tube. Oh yeah, still climbing. Still climbing. Let me say one more caveat before I split away from this. Okay, so we tested these tubes. This is not the end-all be-all super bee's knees of all tubes testers. It's got a plus or minus of like 5 to 10% on its accuracy. I am sure that these tubes are well at 100%. I'm just not letting them cook long enough because I'm running out of time for this project this afternoon, but I just want to get these to where I can put them inside the amp and let them sit there and idle for a few hours before I come back to it this evening. I now know that these 6 tubes more than meet my requirements. There's no shorts, they're not questionable, they're not in the bad range. They're in the high 80s to 90s plus 100%. So, if you're watching this video, don't think I'm out here criticizing what I got, because I'm perfectly satisfied with these. Even in this range on the window, don't touch the plastic. In this range on the window, we're still going to get full output out of the tubes, for the most part. So, on that note, I'm off. We'll be back. Well, let's turn this on. And the tubes are warming up. So we're going to let it sit here and run for the next 3 or 4 hours and just kind of let all of these really old tubes just kind of bake in and just let the internal getters do their thing. Give ourselves the best opportunity for success here. So we're in, we're on, we're idling. Let's grab all the old low tubes. We'll sit them here. And take our case screws and sit them there. Now we're going to go off and work on some other projects. So, yay, fun. So there is no high voltage on the circuit, as we can see here. We're grounded over there. Top of the anodes are dead. This is dead. We don't have anything attached to the top of the tubes. The tubes are well cooked in at this point. The anodes are not attached on any of the tubes, not the drivers, not the finals. So now what the customer states. Well, I keyed it and then the fuse blew. So I have crawled over every square inch of this thing for the most part. I don't see or mentally detect, visually see any kind of problem. I mean, there is that little burn that's down here on the inside of this case wall. But I've crawled all over the high voltage wires. I've looked at the plate wires. I've looked at everything that would go and cause that problem to be there, that burn mark. And I just don't see it. I don't see any blown up chokes, no arced out wires. I don't have any burn traces, no blown diodes. None of the capacitors are leaking. But we don't know until we test it. So, what we've got going on is the amp is in standby. Okay. Let's go over here. Well, no, I want to be over on the other side. Whoop, almost knocked my microphone off there. Okay. Amp's in standby. We're going to use the bench 2950. We want to run our dead key way down. So we've got a 5-watt slug reading for it. Now, we're not going to see anything coming out of these other 2-watt meters because, well, guess what? There's nothing attached to the anode of the tube, so there's going to be no amplification going on. All we're doing here is we're going to see when we key this thing if it decides to let the magic smoke them out. Because something could be shorted up chain, and I don't know what it is, and I haven't seen it yet. The possibilities are there. Come on. Let's see, I want to short fuse this. We're on a 30 amp committed outlet. So if we manage to let the smoke them out, None of the lights are going to shut off in here is what I'm getting at. So I short fuse this. Let's see, let's take that 10 ampere out. And what are you, Chinese infuse? 5. That'll be perfect. There should be no load to the electrical system here when we key this. Now the high voltage is switched on this particular model with this relay in the back corner. So every time you fire down the mic, it detects the RF and it goes into transmit mode. It brings the high voltage section on. Like I said, there's nothing here that I've seen that makes me go, that's what our problem is. Let's see what happens now. So we're able to talk through it just a second ago. Let's put on our hearing protection and our safety squints just in case some parts blow out of here. I don't mind a small scar on the face, but my eyeballs, yeah, I like those in my head and undamaged. So let's see what happens. Ooh. Ooh. Okay. Okay. All right. Oh my God. That's almost embarrassing. That's hilarious and almost embarrassing. I literally looked right at that like 5 times and never even thought that that was a problem. Okay. So this is our blocking cap for our driver's section. These two tubes, these two tubes drive these 4 other tubes. And I must have looked at this probably 10 times and never saw what was going on. This disc capacitor had worked itself down to where, let me grab my insulated, here, you know what? Let's let this bleed off for a hot second. I'll show you what happened. This is dumb. I should have seen this. I'm slipping in my old age is what it is. Okay. 90 volts coming down. Coming down. 90, 87, 86, 85, 84, 83. Anyhow. Okay. Let's not stick our fingers in here for a few minutes still. This leg of the blocker was just barely making contact. Our high voltage comes up on this rod. Our RF goes through here. This is our quote air parentheses plate choke here. There's 45, 40, 52 volts still present. The leg of this disc capacitor was just barely making contact here on that rod. And that caused the high voltage section to arc over. So, okily dokily. Now the $6 million question is what happens when we fully charge the circuit. So let's reach over here. Let's grab the granddaddy chicken stick here. We'll go to case. telling you, capacitors are persistent. Okay. With one hand and one hand only. Now, the same problem can occur just like this. Look at this. Bzzz. We're gonna have a problem if we do it like this. So, much better. Now we've got a bunch of aerial clearance. So, now the plate voltage is piggybacked. Literally, it comes off of a piece of wire down here, and it crosses underneath the cabinet. It comes up to the bottom side of the plate choke. So, still dead. And you know, guys, dog hair and spider webs are bad. Absolutely bad. Because they can conduct, but not at this low voltages, 1,000 volts. All right. Now, we've only got it, we got it fused at 5 amps, don't forget. So, now for this whole separate test. So now we've got voltage on the anodes. Let's, once again, hearing protection. Safety squints. Put this in standby. Nothing happened. That's good. In low, AM only. I'm pretty sure he cut the preamp transistor out of this thing. So, all right. That is encouraging. So, the record, that's 1,000 watt scale here, 1,000 and average 5 watts, so I'm reading forward at the moment. Okay. Now we're making some power. Remember, we're only putting a watt in it. See, check it out. A little bit less than a watt. So, we're in the low mode. Speaking of which, I want my FLIR. And let's go ahead and shut this down for a second. Unplug this thing. All right. Let's pull the 5 amp fuse out. Put the 10 ampere back in the hole. Let's plug this back in. Boot the FLIR, open the FLIR window, turn the amp back on, let it come back up in temp. What's interesting is in low, I had to adjust the driver knob to get anything out of the final state. Okay, well, is what it is. Let's see, tubes are idling at 125, which is perfect. Nothing on the board's getting hot. Nothing in the rectifier chain's getting hot. Good. Okay, we're gonna go to high mode. Okay. Put that in standby. Turn this up a little bit. Put about 3 watts in it now. Back into operate. It's a 100-watt carrier. Oh, that is tight on the tune. Plate, we're running out of capacitance. All right. Oh yeah, we're fine. There's 6. Like I was dancing around. Oh yeah, you smell the dust burning off everything in here. This thing is dirty. Okay, it's not the transformer getting hot. Transformer's idling it at 600 degrees. Rectifiers are 88. Tubes are 173, and over here are 204. Just a little hot, which tells me it's out of tune. Okay, time to keep playing. And I gotta fire up the spectrum analyzer. So you remember how the thing was fluttering? Well, this is our plate tuner. I started looking at that plate, the plate tuner, and then I noticed that this piece of porcelain was broken, this corner tab. And what was going on was that this plate was shifting around and it was just barely making contact. So I kind of wiggled it around a little bit, went and keyed it up, and it goes zap pap. That was it. End of the conversation. And I went, holy shit. I thought, man, did I just wipe out my 4 tubes? Yes, is the answer to that question. These are the 4 brand new tubes, immediately were destroyed. Oh, son of a gun. So I went and I dug around, and I got us a brand new tuner out of parts and replaced this tuner, this one here. And I was like, well, son of a bitch. All of these tubes are now below emission levels. It's depressing because I just bought them all. And in the same breath, we figured out what was wrong with it. Too many fingers in the pie. And shit broken that you just normally wouldn't see. I went to unsolder the tank coil from it. And that whole plate fell out. And this pin came completely off with this plate. So not only was this plate, you can see where it was burning down inside this pin here. All black and scored up here. But this ear was knocked off. So how this works is this plate would, let's say it was on this side. This plate is pressure suspended inside of this porcelain, like so. And then this pin is pressure supported inside of this plate, and these plates are soldered to this bar. Well, when you go and you take the tank coil off, and this comes off with it, and then this plate was hanging on by a pubic hair, that tells me this whole tank coil was just effed from the word go, or the whole plate tuner was effed from the word go. But oh, audio. So this is a 5-watt slugging forward over here, 1,000 an average, and then yeah. There's 4. I got to give it a second here. Oh, there's 6. Oh, 1, 2. 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 Oh, audio. 1, 2. Oh, 1, 2. This is the best of the old tubes. Okay, so we're running on a tube like this one here in the back corners. That one over there is in 35%. The one in the back left over here, this one here is like 60. That's 60. Needless to say, the tuner going bad is what killed the tubes. It's not a mechanical thing inside the amp. Well, this would be a mechanical failure. Don't get me wrong. It's not like a filament volt issue or a bias control issue or other physical component failure. Straight up, these tubes were running into the ground, and then this tuner literally just fell apart. New tuner, fixed that, cleaned this tuner, moved that blocker around, put new tubes in it, the thing took off. So, the only reason it was important for me to show this running is because now that we've identified what the problem is, first thing that we had to do was identify the type of tubes it took. Then we located the tubes that were in this menagerie of shit over here that I call my shop, tested those, found out they were bad, went out and bought 4 new tubes and still hadn't recognized that this was a problem. Discovered this was a problem, and in the process of discovering this was a problem, wiped out these 4 tubes. Now, I almost feel bad about that, but at the $14 to $22 a piece price, lesson learned, right? But at the end of the day, Eagle 750 fixed. Now, I will tell you, before this plate decided to shift and short out, this thing was taking a 1,000-watt slug and just beating the shit out of it on the end of the scale. I'd probably guess it was making 1,200-1,300 watts the way it should. On these depleted tubes that are having a hard time getting with the program, still making almost 700 watts of power. The box is not physically broken, it comes down to the tubes. So I'm going to go to the customer and be like, dude, do you want me to buy 4 new tubes and put it in here and redo the test? Or do you just want me to send you back the amplifier, show you what you need to do, which this is what we're doing, and you go out and purchase the tubes and put them in there and run them through that start process. Let them cook down for like half a day, then come and put the anode tops on them and then tune it out. Where I found the knobs to be at their happiest place is not too far from where all the indicated marks are at on the front. This one don't count because I had to take it off to physically re-index it, so. But this gives me hope. This tells me that the driver section's right. The driver tubes are great, by the way. The driver tubes are still at 85–90%, just the way they were when I put them in there. It's the final tubes that took the punishment. And it all come down to that bad plate tuner, so. On that note, I think no matter what I choose to do with this or what the customer chooses to do with this going forward, as far as you guys in YouTube land are concerned, we're done. I am going to chalk this up to victory because now it's not an issue of an electromechanical thing here, like something going on here that we need to be concerned with. It's just down to the quality of the tubes. This here bums me out. Like, it really makes me sad. Those tubes have managed to make it 60-something years and only come here to get crib death. So it makes me sad as a technician, but in the end of the day, amplifier's fine, I'm fine, and that's life. So, gentlemen, on that note, I want to say thanks. I appreciate you all tuning in. Golden Eagle 750, actually not that bad of an amp. This is simplicity at its best. And yes, he did cut the preamp transistor out of here. He says that he's got another one, or he's going to take that on as doing that part of the repair. I didn't need to worry about that. And I said, oakley dokley, no problem, because everything else on the front of this works. On, off, operate. The plate gain, which is a wire intertwisted with some other wires back in here. This needle does wiggle and it goes to about 50%, but that's about all she wrote. And I think it's a mechanical issue inside the meter, so I don't have a replacement meter. There's nothing I can do about it. Other than that, I'm willing to sign off on it. It's a bummer because then I don't get to show the big watts and be like, ooh, look at me, I'm a TV antenna. I don't get to do that here. Lame. But is what it is. It's still fixed. It's still running, and life is good. Gentlemen, I appreciate every single one of you. Big shout out to the Patreons, Siglent, McMahon, Bird, Coaxial Dynamics, and a big thanks to every single one of you guys. Oh, I gotta go find something else to do. I'll see ya. Click, click, click.